right, everybody, we are still in chapter 6. We're looking at section 6.5, which really isn't much different than the stuff that we've been talking about before in section 6.3 and 6.4. So I don't want you to think this is a whole bunch of new stuff, but what we're going to do is determine what method is best. So we actually now have three methods for solving linear equations or systems of linear equations. We've got graphing, which nobody's particularly fond of because it takes a long time, right? And it's not as specific as we'd like it to be. We have substitution, which is pretty good, and we have elimination. So now you're going to have in this next set of problems an opportunity basically to see which one works best, right? So we're going to talk about techniques for determining that. So this is going to be a pretty short video, hopefully. We'll see. And we're going to just talk about, there's no vocabulary, so we'll just talk about the best method. So as I look at this first problem here, I guess I should grab a pen and maybe I'll write in white. Okay, so I'm going to call this part A, number 1, part A. As I look at this problem here, again, I'm going to solve the system. I'm trying to figure out what's the best method. Now, your textbook looks at this and says, hey, this y is isolated, it doesn't have a coefficient, it's all good, you should probably solve by substitution. And that is totally reasonable. I guess when I look at this, I'm not sure that I would knee-jerk say that substitution is the best. I'd probably try to use elimination by multiplying this first equation by 2. So the reason why I say that, and I point out that we have kind of a difference of opinion, is that it's what's the best method for you, not for me, not what the textbook says. It's what you feel most comfortable with and what's going to give you the best opportunity for accurate calculation. So as I look at this one, I'm going to follow the textbook's advice because it is not what I generally would want to. So let's take this equation and we're going to solve for y. When I do that, I end up with y is equal to 19 plus 8x. And you guys can see that from me adding 8x to both sides of this equation, right? So I've solved for y. Now what I'm going to do is I'm going to place this solved version of y into this other equation. So 4x minus 4 times the quantity of, well, times y, but now we're going to use the quantity of 19 plus 8x. Because that is the new method of talking about what y is equal to 8. And I'm going to grab this and move it over here so I can actually work on it. So there's our problem, and let's go ahead and work on solving it. So I'm going to solve for x. So distributive property in full effect here. I'm going to get 4 times 19 is going to be 76. It's going to be a negative 76. This is going to be a negative 32x is equal to 8. I'm going to join like terms together. Since this is 4x and this is a negative 32, I'm going to get a negative 28x when I bring them together. When I add 76 to both sides, I'm going to get a positive 84 over here. So now what I'll do is I will divide both sides by my negative 28. And when I do that, I am not able to do that right now, but let me think about it. I know that 7 goes into 84 12 times, and 7 goes, oh, there it is, 4. So this reduces to negative 3. So x is equal to negative 3. So we have that. The next thing, of course, we've got to solve for y. So we're going to plug that negative 3 right in here in order to solve for y. So in this case, let me use another color just to emphasize. Y is therefore equal to 19 plus 8 times negative 3, right? So y is equal to 19 plus a negative 24, or 19 minus 24 as it were. And then when I add 19 and 24, 19 and a negative 24, I'm going to get a negative 5. So now y is equal to negative 5. And so we've solved it. So you could have also solved this again by elimination method, but it's totally up to you. This next example and the next couple of examples we're not going to actually do. We're just going to talk about how we're going to solve it. So I'm going to, again, try to shrink some of this information so it'll still be here, but it'll just be a little bit more out of the way. So we've got that going on. All right, so what about this next problem? How would you solve it? Would you use elimination or would you use substitution? You have a lot of isolated variables here, x, y, and the other y. This to me looks like a wonderful situation for elimination because you notice that the coefficients of the y terms in each equation are additive inverses. So you're just going to plunk down. I said we weren't going to solve, but look at me. We're just going to add these two equations together. I won't solve it all the way. You get 8x, the y's cancel out. is equal to 16. Look how, I mean, you just want to solve it, even though I said x equals 2, right? Divide both sides, plug it back into the equation. It's hurting, I can't help but solve it. 2 minus y is equal to 9. I'm going to subtract 2 on both sides, and I'll get that negative y is equal to 7. Therefore, y is equal to negative 7. I'm sorry, people, I just had to solve it. So I get y is 2 and negative 7 will be my answers there. Does that kind of make sense? Do you see that? I hope you see that in any case that you can do it a couple of different ways, but sometimes you just need to see what is the best way. I promise these next two we aren't going to solve, okay? You guys can solve it on your own. But here's example 1 continued. What method would you use here? Would you use substitution? Hopefully not. To substitute here, it would be a little bit hard to isolate our variable, either y or x in either equation. It looks like this would be a great opportunity to maybe call this a green equation and multiply both sides by this particular equation by what to get rid of the what? Let's just get rid of y, right? Multiply both equations by 2, then we would get that the coefficient here is a negative 8, which makes it an opposite, an additive inverse, which is what we're looking for. How about this equation over here? What do you guys think? We have 5x and 3x, y and 2y. We could isolate this y, do a little substitution, right? What else could we do? We could also do elimination by multiplying this first equation by the number 2, kind of like the last one. If we did that, then we get to isolate y. Of course, we could isolate, we could eliminate y. Of course, we could eliminate x. But to eliminate x in either of these equations, we'd need to multiply the top by one number, the bottom by another number. It's a little bit more work. So again, we're looking for efficient, effective work. We're not looking for a specific method in this section. So you have your choice. Okay, so this last problem is basically an opportunity for us to practice our skill with solving systems of linear equations, but we're going to do it given some information in a word problem. So we've got, when you read through this, we've got an emperor species of penguins and the Galapagos species. And the emperor species are large, the Galapagos species small. What we have is now some information. So if the sum of their average heights is 169 centimeters, and the emperor penguin is 22 centimeters taller than twice the height of the Galapagos penguin, what is the average height of each penguin? Well, first of all, we know we're looking for the height of both penguins or either penguin, so let's use, I guess, E for the emperor penguin's height, and then we can use P for the, or G would probably be preferable for the Galapagos penguin's height. Now that we have that, we know that if we took E plus G, it would equal what? Well, let's go back. It says if the sum of their average height, so E and G are the average heights, if the sum of their average heights would be 169, so that's one equation. How will we get the next equation? When I look around, I see that there's more information. In fact, it's comparing the height of the emperor penguin to the Galapagos penguin. So we see that the emperor penguin is something in comparison to twice the height of the Galapagos. So I like to start off trying to figure out what they're saying by doing this. I know that it is being compared to 2 times the height of the Galapagos. Now, where am I going to put this 22? So I read the sentence again. And the emperor penguin is 22 centimeters taller than twice the height of this guy. So if this emperor penguin is 22 centimeters taller than twice that, then I'm going to either have to subtract 22 from the emperor penguin's height in order to make this equal, or I will add 22 to the height of double the Galapagos penguin's height. Blah. I hope that makes sense. I hope that's not as crazy as I felt like I was sounding. But so here we now have 2 equations. And again, this could have been minus 22. But I like this because now E is solved for. And this to me screams substitution because E is already solved for. So I'm gonna use what I got. So I'm gonna use this to plug it in here. Though these 2 E's look different, I apologize. So I'm gonna do 2G plus 22. That's what E is. Plus G again is equal to 169. It is terribly bothersome that I wrote that between colors. So I'm going to, I don't know, shift it somewhere. Maybe shift it down. All right, there we go. So we've got that. So this is the equation that we're working on. And let's scroll down a little bit more. Matter of fact, maybe I should shift it over here. Sorry, people, I'm making a short video long. All right, so now we're going to finish this problem by solving for G, and once we solve for G, we can then go back and solve for E. So I'm solving for G by saying that I'm going to join like terms together. This is 2g and another g gives me 3g plus 22 is equal to 196. Subtracting 22 on both sides as we do, we're going to get that 3g is equal to 174. So now we're going to have to divide by 3 on either side in order to get our answer. So g is equal to 3 goes into 17 5 times with the remainder of 2. 3 goes into 24 8 times. So 58. So 58 centimeters is the height of the Galapagos penguin. And now we've got to figure out what's the height of the emperor penguin. Beautifully, we've got this equation already solved. So E is equal to 2g plus 22. So I'm going to take the information I have here, the fact that g is equal to 58, and plug it right on in. So 2 times 58 plus 22 is going to give me the height, and 2 times 58 is going to be 116 plus 22 is equal to, I'm getting there people, 138. So 138 centimeters, and we're done. Thank you very much. That took a lot longer than I expected. However, that is the end of our video. Again, not really a new lesson, but really just giving you the opportunity to figure out what works best for you. All right, look forward to seeing you guys soon. Please, as always, let me know if there's any questions. Take it easy.